Let's have a look at exercise 1. We're given this function 3x minus 1 over 2x plus 2. We have to find the zeros of the function, or where it's crossing the x-axis. So they're also called the roots. We have to find the y-intercept, where the function it's crossing the y-axis. And then we have to find the asymptotes, if it has some horizontal asymptotes or some vertical asymptotes. We also have to state the domain, all the x values that are allowed in this function, and also the range, all the possible y values of this function. So let's copy it and let's get started. So 3x minus 1, 3x minus 1 over 2x plus 2. That is our function. So before we start with the calculator, we're actually going to use the calculator and do everything basically to check that we're correct, but we have to be able to do this without the calculator. So let's start with the zeros. In A, we have to find the zeros. How do we do it normally if it's, let's say, a linear function or a function of the second degree? If we find the zeros, well, if we think about it, when is the function, a function in general, crossing the x-axis? When y is 0, because if we think about a coordinate system, x, y, let's say any function, let's say this function, is crossing the x-axis here. And for this point, if we go to the left, where we meet, until we meet the y-axis, the y is 0. So if we solve the equation just saying this is 0, when this is 0, we'll get the zeros. So basically solve the equation f of x, which is the same as y, the y value, when it's 0. Let's have a look at this function. This function, a quotient function, can only be 0 when the numerator is 0. Okay, so basically we're going to solve 3x minus 1 is equal to 0. Move minus 1 to the right side, 3x is equal to 1. Divide both sides by 3. We can now cross out 3 left with 1 and 1. Last step, x is equal to a third. And that's the only 0 we have. Okay, that was easy. So we just look at the numerator and we find out for which x value the numerator is equal to 0. That's our zeros, or the roots of the function. In B, we have to find the y-intercept. Okay, so y-intercept, if we think about the graph again, the function is crossing the y-axis at some point. If it is crossing, then we have a y-intercept. What is the x-coordinate at this very point? Well, we just go down until we meet the x-axis. X is equal to 0. So if we insert x is equal to 0 in our function, we will get the y value. So we can just look at this function. So f of 0, 3 times 0 minus 1 is going to be minus 1. 2 times 0 is 0, and then plus 2. So minus 1 over plus 2, so minus a half. That's our y-intercept. So we're gonna write f of 0 is equal to, we can write it out, 3 times 0 plus 1. 3 times 0, I'm going to write 3 bracket 0, that means 3 times 0 plus 1. And then down in the denominator we had 2x plus 2, which means 2 times x, and x is 0. 2 times 0 plus 2. I missed a sign here, didn't I? Yes, it was minus 1. So it's minus 1. This is equal to minus 1 over 2. It's fine to leave the minus sign here, or if we want to move it in front, so minus a half. Same thing as if the minus sign would have been down here, so 1 over minus 2 is still minus a half, or minus 0.5. Okay, that's our y-intercept. Question C, now we have to find the asymptotes. We have to find out if there are some vertical or horizontal asymptotes. So basically, let's start with vertical asymptote. Vertical asymptote. So once again, if we have the coordinate system, our function might look something like, in general, well, actually, let's have a look at this, what we have so far. Zeros at 1/3, okay? So 1 over 3. 1/3, it's crossing the x-axis. We have a y-intercept at minus a half. Minus 1 over 2. That's all we know. If we look at the function when, well, for very large values of x, this is going to be something positive, right? So 3 times something very large, positive number, minus 1 doesn't change anything, and then divided by 2 times this large number of x plus 2 doesn't really change anything. It's going to be 3 times a large number over 2 times a large number. So it's going to be a positive value for y. So maybe it looks something like this. And then the other part have to look something like this. That's our guess. Let's see if we can confirm this, or if we have another idea of the function when we found the vertical asymptote and the horizontal asymptote. So let's have a look at vertical asymptotes. So basically it's going to be a vertical line that we can't see, but if we plot it in here, it's going to be the line that the function would like to go towards. So it's kind of getting closer and closer to that line. It will never touch this line, but it's getting closer and closer. Also up here, it's getting closer and closer to this vertical line. This is the vertical asymptote. And this is the x value that is not allowed for the function. So we have to study the denominator. Is there any x value that gonna imply that the denominator is 0? So 2 times something plus 2, when is that 0? We're not allowed to divide something by 0. That's not allowed. So 2x plus 2. 2x plus 2 is equal to 0. That's the equation that we have to solve. So 2x plus 2 is equal to 0. Move plus 2 to the other side. It becomes minus 2. We divide both sides by 2. Minus 2 divided by 2. We can cross out the 2's. We're left with 1, 1. We have x is equal to minus 2 over 2 is equal to minus 1. Okay, so the vertical asymptote is going to be, the equation is going to be x, well, we have it here already, and just do it like this. This is the equation of the vertical asymptote. Now let's find out if we have a horizontal asymptote. It's a little bit difficult to write with this pad, but it's okay. Well, we're just going to study the coefficients in front of the x terms. When we have this type of function, we have 3x here up in the numerator, and down in the denominator we have also an x term, 2x. We're going to study these two. So basically I'm going to find out the value by looking at the two x terms. So basically we had 3x over 2x. We can cross out the x's. We think that, okay, this is 3 over 2. This is equal to 1.5, or we just leave it like this. So this means, therefore, the equation of the horizontal asymptote is y is equal to 3 over 2. Going back to our little sketch here. So this horizontal asymptote will be at 3 over 2. Okay? Now, let's get back to question D. State the domain possible x values. Well, let's just look at the function. We can put in any x value here, that's fine. The only thing we have to watch out for is when the denominator was 0, and that happened when x was equal to minus 1. So we're just going to write D, the domain of f of x. All values of x, all real values of x, this means all real values of x, but x cannot be equal to, x is equal to minus 1, so x cannot be equal to minus 1. All other real values are fine. And the range of f of x. So y values are all real values, but if we look at our sketch, we're going to have some negative values of y is just going to continue to go down like this. So all the negative values are here, crossing the x-axis, going up here. We're never going to have this y value. All the other y values up here, positive y values, is going to be allowed, but this y value, when we have the horizontal asymptote, so y is equal to 3 over 2, that's not going to be allowed. Okay, so not equal to 3 over 2 or 1.5. 5. All other y values, real y values, are allowed.